Hello friends, today we are discussing about the DC theorems. First we will discuss about the Thevenin theorem. The statement of Thevenin theorem: any linear bilateral network or DC circuit which has one or more than one active source which produce the energy, that is voltage source or current source, and passive element which can store the energy or dissipate the energy, like resistance, can be replaced to single voltage source and single resistance. It means that single voltage source means one active element and one passive element. This network is called as Thevenin model, and load current can be easily calculated from the circuit. So let this circuit having a voltage source V, R1, R2, R3 are passive elements, and R is also passive elements, but it's considered as a load. So that complicated circuit can we convert into, or can we reduction this circuit to single circuit and simple circuit, and that will be the one single resistance, that is called Thevenin resistance or internal resistance, and voltage source. This voltage source is called as a voltage Thevenin or open circuit voltage. So this both passive elements and active elements connected in series, and that represent as a Thevenin model, and load is connected reconnect here, and we can find out easily the load current from the circuit. For solving the Thevenin circuit, we can follow these steps. First step is to remove the load resistance. Whatever the load resistance in the circuit, we have to first remove the load resistance. Second one is a find VOC or VTH. VOC means open circuit voltage or Thevenin voltage. That can be possible when we find out the voltage across the open circuit terminal. And third step is to find the RTH or RI, that is the Thevenin resistance, and that is the possible when we deactivate all the sources. Suppose if deactivate the sources, if voltage source is there, voltage source can be short circuit and current source can be open circuit. So for better understanding, we can solve one problem of by Thevenin theorem. Here is the voltage source is given 10 volt, resistance are given 10 ohm, 10 ohm, 10 ohm, and load resistance is given as a 10 ohm. Now first step, we have to remove the load resistance. So load resistance is here is 10 ohm. So we remove here load resistance. So after first step, our circuit will be become like this. Now the second step, we have to find out the open circuit voltage or Thevenin. So open circuit voltage is terminal which is where the load is removed, and we can consider it as a imaginary battery. Now we will find out the voltage across the open circuit voltage. Now first step, we can find out easily the current is flowing, the closed circuit is I. So we can find out the resistance of the closed circuit 10 ohm, and 10 ohm are in series because current is not going in the open circuit terminals. So because of there is an open path, so no current is flow in this path, so all current is circulating through this closed path. So we can find out easily I is equal to V upon R, and the current is going through this circuit. 10 ohm and 10 ohm resistance will be there. Total resistance will be 20 ohm. So we can find out easily 10 upon 10 plus 10, and that is equal to 10 upon 20, or that is equal to 0.5 ampere. So 0.5 ampere is going through the 10 ohm resistance, and this 10 ohm resistance is parallel to open terminals. So we can find out the drop across the 10 ohm resistance. So we can find out drop across 10 ohm resistance, and that will be the V1, and that V1 is equal to I into 10, that is equal to 0.5 into 10, and that is equal to 5 volt. So V1 is the 5 volt, and this 5 volt is across the open terminal of the circuit. So that is also called as open circuit voltage. So our open circuit voltage will be VOC, or that is also called as Thevenin voltage, that is equal to 5 volt. Now in third step, we have to find out the RTH. In third step, we have to find out the RTH. Again we will make circuit 10 volt, 10 ohm, 10 ohm, 10 ohm, and this is 10 ohm, and this is the load resistance 10 ohm RL. So find out the RTH of this circuit. We can find out, assume that this is circuit and we have to find out the RTH. So RTH is the internal resistance of the circuits. Again we will make circuit. And after removing the load from the given circuit, we are getting circuit like this, and this is the open circuit. Now this battery is work as an imaginary battery, and for that we can see from here the current is flowing through the circuit. Now for getting the RTH, so first we have to deactivate the sources. If voltage source is there, that will be short circuit, and if current source is there, that will be open circuit. So we follow this rule. Now we will make deactivate of the voltage source by short circuit. That's 10 ohm. This is 10 ohm. This is 10 ohm. Now we can find out the RTH easily. The current is going from this. The resistance can be calculated according to the flow of current. So current is flowing from this direction, imaginary battery. So current is going for this point, is divided. So these two are become parallel because current is division here. So they are in parallel condition. So that 10 and 10 will be parallel. So RTH will be equal to 10. 10 is series current is flowing. Then it is divided parallel. So 10 is become parallel. So 10 plus 10 parallel to 10. So we can find out 10 plus 10 into 10 divided by 10 plus 10, and that is equal to 5, and that is equal to 10, that equal to 15 ohm. So now we are getting the RTH value is 15 ohm. So from first step we can find out VTH, and the third step we can find out RTH. So now we can make a Thevenin model, and that will be the voltage resistance and voltage source, and that is VTH, that is equal to, we can find out 5 volt, and RTH is equal to 15 ohm. Now we have to reconnect the load. To reconnect the load, whatever the load is there in circuit 10 ohm, we again reconnect in the circuit. So now we can find out so this is the Thevenin model. So this circuit is simply reduced to this circuit. Now we can find out the IL or load current easily by KVL, and that is equal to VTH upon RTH plus RL, and that is equal to, here VTH is equal to 5 upon 15 is RTH and RL is 10 ohm. So we can find out IL is equal to 5 upon 25, and that is equal to 0.2 ampere. So now from this theorem we can find out easily load current. This is all about the Thevenin theorem. Thank you.